So let's now go through one more example of building a 2-4 tree. So again, in building a 2-4 tree, we start the same way we would as a 2-3 tree. We search for the leaf where the new element would go and we'd add there. Again, we don't create a new leaf, we just add to the current leaf. The main difference is if during this search we find a 4 node, we split right away. So we are allowed to have 4 nodes in a 2-4 tree. We only split them if we encounter them during a search. Okay. Once we do a split, we keep looking. Now, if we do a 4-node split that creates another 4 node, we just keep going, right? We don't kind of go back up and keep splitting. We just keep looking for the proper place. Okay, so let's trace through an example. So we're going to add 8, 6, 9, 12, 10, 4, 7, 5, 3, 2, 11. Okay. So we'll start off with the 8. That's a 2-4 tree. Now we want to add the 6. 6 goes to the left of 8. So 8 is the leaf where it belongs. So this now turns into a 3 node. We've added our 6. Now we want to add our 9. That goes to the right of 8. So this turns into a 4 node, but that's okay. We are allowed to have a 4 node in a 2-4 tree. So this is allowed. This is a valid 2-4 tree. Now it's time to add the 12. Now, in searching for where to add the 12, we hit a 4 node. So we kind of put our search on pause and we do a split. And the split happens in the same way that it did for the 2-3 trees. We take the middle element and we bump it up. In this case, it's just going to turn into a new root, right? So we'll make 8 the new root. And then we take the 6 and the 9 and make them 2 nodes. Link everything back up. And so this is what the result of our split. And again, now we just continue to look for where the 12 goes. So we left off here at the 8. So again, we go to the right. 12 belongs to the right of 9. So I insert it there and create a 3 node. Okay, so that's what my tree looks like so far. Now I want to add the 10. So 10 is bigger than 8. I go to the right. 10 is between these values, so I'm going to add it. And I'm done. I'm allowed to have that 4 node there. So this is a legal 2-4 tree. That is allowed. Now I'm going to add my 4. 4 is to the left of 8. So I go here. I find the leaf where it belongs. And I add it. This now becomes a 3 node. That's allowed. Add my 7. 7 is less than 8, so I go left, add to the right of 6. That becomes a 4 node. Again, that is allowed. So at this point, this is my tree. This is a valid 2-4 tree. Okay, now I want to add my 5. So 5 is to the left of 8. When I go left, I hit a 4 node. So I put my search on pause and I do my split. To do my split, I take that middle value and I bump it up. So now the 8 is going to become a 3 node, and then I take my 4 and my 7 and I convert them back to 2 nodes and link them back up. You can see again that this is still a valid tree because to the left of 6 is less than 6, the 7 is in the middle, that's in between those values, and to the right is greater than the 8. Now I resume my search for the 5, so that's still going to be to the left of 6 and 8. So I go to the 4 node, that's the leaf where it belongs. So I insert it there, converting that into a 3 node. Okay. Now I want to add a 3. So 3 is less than 6, so I go left. I hit here, less than 4, so I add it to this leaf, and that becomes a 4 node. Again, that is allowed. I want to add my 2, so I search for it. 2 is to the left of 6, so I go here. Now in my search, I've hit a 4 node, so I stop and I do a split. For my split, I take that 4 and I bump it up a value, up a row. Now, what this has done is it's created a new 4 node, but that's okay. I don't worry about that. I'm allowed to have that. Okay, I don't propagate that split up. So that's a kind of a difference between the 2-3 and the 2-4. I just carry on. So my carrying on means I make my 3 and 5 nodes back to my 3 and 5 nodes back to 2 nodes. Link everything back up. You can see again that now we've got a valid tree because the smaller than a 4 is to the left. The 5 is in between the 4 and the 6. The 7 is in between the 6 and the 8, and greater than the 8 is over to the right, so that's a valid tree. And again, now I resume my search for the 2, which is going to bring me to the left of 4, and I insert it there into that leaf, which then becomes, again, a 3 node. Now, some people kind of find that last part of searching confusing because they think, well, aren't I finding this node as part of my search? But I'm really not. I created that node as part of my search. So that's kind of a tricky distinction there. But when you create a new 4 node and then you resume your search at that 4 node, you don't count that as having made a split. You just keep looking in the direction you need to go. All right, so last up, I'm going to add my 11. 11, when I start to look for it, right away I hit a 4 node, so I do a split. To do a split here, I'm going to make the 6 bump it up a level, which is just going to turn it into a root, and then I'm going to convert my 4 and my 8 back to 2 nodes, and then link everything up. Again, you can see that this is a valid binary search tree. So everything to the left of the 6 is smaller. Everything to the left of the 4 is smaller than 4. To the right of 4 is greater than 4. Everything to the right of 6 is all greater than 6. To the left of the 8 is smaller. To the right of the 8 is greater. And now I can resume my search for the 11. So I go to the right. It's bigger than 8. I go to the right again. But then now I pause because I've again hit a 4 node, so I need to do a split before I continue looking. So to do my split, I'm going to bump the 10 up, turn this into a 3 node, and then the 9 and the 12 will get converted back into 2 nodes, linked back up, and again, you can see that this is still a valid binary search tree because the 9 is in between these values, 12 is greater than, and now I can resume my search for the 11, which goes to the right of the 8, 10 node, which I will add it to the 12 leaf, turning that into a 3 node. So this is going to be my final tree. And you can see that it's very balanced, right? There's a lot of numbers here, but it's short, so it has a small height. It's very balanced, which is again the purpose of these 2-4 trees. You can also review that it's got all of the characteristics of a binary search tree. So everything over here is smaller than the 6. Everything over here is greater than the 6. And for the 8, 10 node, nodes in the left are smaller, nodes in between are in between, nodes to the right are greater, and everything left of the 4 is smaller, right of the 4 is greater. Okay, so that's the process of creating the 2-4 tree. Again, I think kind of the trickiest part is that idea that you split a 4 node when searching, but if that split results in another 4 node, you don't consider that as encountering another 4 node, you just keep going.